Please note, before we begin, the following mock ship check demonstrations are intended for educational purposes only. These scenes were filmed inside mock ship compartments, and personal protective equipment, PPE, was intentionally not worn to clearly show each step of the process.
All right, Brian, so what's the next job you got there? So we got to be in this space. It said 143 TAC 1 Echo, right?
For saltwater pump.
Number 1, right?
Number 1.
All right, so we validate here. This is one thing we can validate is the bullseyes for sure. First deck, 43rd frame. This is the forwardmost frame as well. Starboard side and the engineering space, which you can see engineering space usually has your equipment that you use for engineering. Potable water, seawater service. 43 through 46 is the frame numbers that this space would go through, from 43, which is the forward, to the most aft bulkhead, which is 46, and it's owned by E Division. Okay, that's what the bullseye does for us. So now we're looking for seawater service pump number 1. What would be one of the things, the color that would give you an idea which one it is?
Green.
Green is seawater service, correct? Or
yes,
any
sir.
kind of seawater cooling, okay?
Yes, sir.
So what pump do you think it would be? Blue?
I would think it'd be that one.
That one right there, correct. So how will we validate that?
The color and the data plate.
Data plate says what?
SWS pump number 1.
Okay, so that's what you're looking for, right?
Yes, sir.
Seawater service pump number 1. Okay, to explain something to you, when these jobs are written, you have to read these jobs very closely because some say motor and some say pump, or some say motor and pump, and as an assembly, okay? This is an assembly. This is the motor.
Okay.
This portion that bolts on the front is the pump that usually has the piping attached to it, okay? So this, what it's setting on, is what's considered the pump's foundation, okay? There's usually, it's not here, but the mock-up, but then on a real ship you'll have rubber grommets in there. They're called resilient mounts. They reduce the noise that the pump makes through the hull, okay? So what we want to look at is, they're calling out for this assembly to be replaced, so what we need to do is make sure that we're going to look at one thing. Okay, we already know that they're going to replace this pump, or it's going to have to be rebuilt. They already called that out, okay? So now we got to figure out is what size pump we have, what size piping we have to tie to it. We need to look at the foundation and make sure once they remove it, is the foundation in good condition? If not, we need to get it fixed. If it does have resilient mounts, how many and what type? They usually, when they pull a pump, they just go ahead and replace the resilient mounts anyways, because it just makes sense. They're cheap. Why would you put an old resilient mount back with a new pump? Doesn't make sense, right? So once you look at all that and we determine what that is, then all you're going to need to do now is what do you think we would need off this pump to help the planner out at this point?
The measurements, the pipe size.
Okay. What would be on the motor or what would be on the pump that would be detrimentally helpful to them if we can get it? The data plates, right?
The data plates, yeah.
There's data plates on board. This one it would be like for the electrical side of the house. You'd have like a Reliance motor here, and then over here you may have a Weber pump or something like that on it. They usually have the little plate, and it'll give you a serial number, a part number, what size it is, what it's rated at, whether it's 500 gallons a minute, 100 gallons a minute, or whatever. Primarily, what we want to do is when you take a measurement, we will take a measurement with a pipe sizer. You'll put it on the pipe. You push this in as far as it'll go till it touches the ring. You push down on it and hold, and as you can see, the piping measures out at 1.5 inches. Okay, so this is a 1.5 inch piping. Okay, now sometimes you can also look right here on the flange itself, which if you want to get a close up of that, they're marked as such. So this is 150 WOG, and it says right there 1.5 inches. So it's 1.5 inches full bolt flange. That's another thing you want to make sure, because if the pump's full bolts, they probably have that version that size in a 6 and an 8 and a 10. So
Gotcha.
You need to let them know that it's a 4-bolt flange, so they order the right one. If they have to replace the piping or anything that's off of it. Then sometimes when they bring in new pumps, they modify things, they change things over the years. So they may have to modify the piping to fit back to the pump, retrofit it, you know what I'm saying, which is kind of what you kind of factor in. So now we've determined that it's 1.5 inches. So what size pump do you think that pump is now?
It's 1.5 inch pump.
You can pump into 1.5 inches.
Okay.
There you go. And this would be your discharge side, and this is your suction side. Okay, suctions come in the middle and go out the top. That means it goes out and feeds everything else. Okay.
Gotcha.
So what would be one other thing that we could get them that would help them with their planning? Because what would we need to do to work on that electrical motor? What do we need to do? You
shut
ever heard
power
of the
down.
tag out procedure, right?
Tag out procedure.
We want to tag it out electrically so
Yeah.
that we can make it safe. So what we will do is go look at the cable, like we have here. The cable's up here. And you will look for a cable right here. Here's a perfect one. We would look at the cable designator, okay? They'll have one where it plugs into the pump, okay? That will tell you where is load center, what load center it's tied to, what fuse box it might be phased out of, or anything. So that's very important. If we can get that for them, it helps the planner a lot.
Okay.
As far as planning for that, okay? Such as like any kind of lighting, you'll see them on most anything that has lighting or anything. You'll see these cable tags. They should be. Now I'm not promising you they'll always be there. So, and the thing about it is some of these runs go 600-800 feet, and they usually try to put one on one end or the other. But sometimes they put them in between. But if you're in between the two ends, you don't know which one of these 400 cables is the one you need to look at. Okay, so basically. Now that we figured that out, you've written all your stuff down, you got your data plate info, stuff like that. So now we just need to take some pictures of it, right?
Yes, sir.
So let's go ahead and get our camera and go ahead and take a couple snapback pictures of it. Kind of tell me what you would be taking pictures of. First thing we want to do is the bullseye, right? Show them that we're in the right space. Okay. Then we want to go ahead and do a backup a little bit. And if you can, sometimes it helps if you can show the pump and the bullseye
All right.
in the same picture. It kind of lets
Yeah.
them know that you're definitely in the direction.
Okay.
All right. Then we would want to get that. There you go. The data plate where it's labeled as a seawater service pump number 1. We want to take a picture of, yeah, exactly, of the pipe sizing, the 1.5 inch. Yep. And then we want to make sure we get the data plate on the motor, and we want to get the data plate on the pump. Blah, blah, yep. And then we want to get the cable clamp that would be there. And I will tell you these, a lot of times it helps put your hand behind them because they're stainless, so they're very shiny. So sometimes if it flashes, you won't be able to see it. So if you put something behind it, it absorbs some of the light, and it makes it easier to take a picture of, okay?
Gotcha.
So now we need to make sure we get good pictures of the foundation to show that whether it's good or bad. Okay. On different angles, go to that far end, take one of the long ways, there you go. All right. And that would be, then we would just write down all this information like that. Now, the other thing that you want to look at, this one is relatively a small pump for this ship check, okay? What if it was a fire pump? Fire pumps stand this tall and they're this wide. Is it going through that door?
No.
Is it going through that door?
No.
How would you know?
Measuring.
So if you measure the width of the motor itself this way,
Yeah.
including this stuff,
Yeah.
you go to that door. If it's 26 inches wide, but your pump is 40 inches wide, what do you think we need to call out at that point? You have to factor that in as well. We need something else. Temporary access opening.
Temporary access,
TAO. So you may want to recommend via PCFR, say PCFR recommended, pump is larger than any exiting spaces, open doors from the space, okay? So that means that clues the planner in and goes, oh, you know what? They're right, that pump is way bigger than any door that's in that space. That means we're gonna have to find out what bulkhead, which we don't make that determination.
Yeah.
That's a structural engineer. We don't just make cuts on ships without randomly doing it. Yeah. So they'll bring in somebody and they'll say, okay, you can cut a 4 foot by 4 foot hole in that bulkhead that's right behind you, okay? That carries you out into the main space where you can take it out any other door, or it's like it's in the hangar bay or something like that, so we can get it out easier, and then we can get it off the ship and then bring the new one in. So that means that will stay open until the new one is brought in and installed. Okay, once that is done, then they have to go back and refix that, okay? So, I mean, at a minimum, that's something you need to bring up. I understand that you won't know what there's installation or whatever, because you don't know where they're going to make the cut.
Yeah.
But it's already been invoked that they're going to do the TAO, and a lot of times when they cut off installation stuff to do that, it's automatically invoked that they have to replace it.
Gotcha.
They can't charge you extra for it. Okay, so whatever they take out, they have to replace back to original configuration. So this one would definitely fit out that door.
Yeah.
So what would be the last thing that you would need to look at? If this pump stands this high, are you carrying it out of here?
No.
What do you think needs to happen? How would you get it out of here? Look right behind you. There's something hanging there. What is that?
The chain
Chainfall.
fall.
So in other words, we would need to rig it out, correct?
Rig it out. Okay.
So you need to have a rigging path at this point, right?
Okay.
You need to call it out. We don't make rigging paths because we're not riggers. We don't know how they're going to get it out of the space, but you would want to call it out. This one, you think you could, 2 people probably could carry this out safely and not get injured, right?
Yeah.
But if it's a fire pump, say for instance, it's like the big ones that are outside.
Yeah.
These things weigh 700-800 pounds, if
Yeah.
not more, especially the motor part of it because
Yeah.
it's all copper wire.
Yeah.
So we have to rig those out. In other words, then that means they got to come in here and figure out where they're going to put their clamps, how they're going to slowly get it to that door to get it out off the ship, okay? So these are things that you got to think of that's not called out in a ship check that you have to think of outside the box, okay? These are what we have to make sure that the planner knows, because if we're here, we need to make sure that they can get it out of the space safely, they can get it out through the doors that are available, and or they're going to have to do a TAO, or they may have to rig as well, okay? So those are exponentially things got to be looked at, all right? So other than that, I believe that's about it for the what we would call machinery ship check, okay? Basically with machinery, we already know they're either going to rebuild it, fix it, or replace it. So basically what we need to do is just get the data plate information off of it. Like an engine, if they're going to replace it, you take a picture of the engine, you take a picture of the data plate so I know which one they need to order.
Gotcha.
That's basically it, okay? But we need to make sure that we get that, and if it doesn't have a data plate on it, we need to get with the ship and get some kind of documentation that shows what that motor is, or whatever piece of equipment needs to be replaced.
Yeah.
Okay?